In this video, we're going to learn how to solve simultaneous equations graphically. So you would remember from a few videos ago, we learned how to solve simultaneous equations when you have two different equations and two unknowns. And we learned a few different ways that we can solve those, but today we're going to learn how to solve them graphically. So if you're given two graphs on a Cartesian plane, you can easily solve a simultaneous equation. So let's start off with these two equations here. We have two equations and we have two variables. We have x and we have y. So the way that we're going to start off when we are trying to solve simultaneous equations graphically is to rearrange our equations in terms of y. So let's put both of these equations in terms of y. So if we're starting out with this one, if we want to isolate for y, we have to move this 2x term to the other side. So this is going to become y is equal to 3 minus 2x. And that's because we had a plus 2x here, so if we move it to this side, it becomes minus 2x. Now let's do the same thing with this equation here. If we're isolating for y, we're going to move this plus x to this side, so it's going to become a minus x, and this is going to become y is equal to 1 minus x. So we have now put both of our equations in terms of y. And now what we can do is we can try to get some values for x and y so that we can start plotting these graphs onto this plane. So let's start off with this first equation here. Let's try and figure out our values for y when x is equal to different values. We know our equation is y is equal to 3 minus 2x. So if our x is equal to, let's say, negative 1, then our y is going to be equal to 5, because 3 minus minus 2 is 5. Now if our x is 0, our y is going to be 3. If our x is 1, our y is going to be 1. If our x is 2, our y is going to be minus 1. If our x is 3, our y is going to be minus 3. And if our x is 4, our y is going to be minus 5. Now let's do the same thing for our second equation right here. Let's try and figure out some values that we would have for y with different values of x. If our x was equal to minus 1, our y would be 2. If our x was equal to 0, our y would be 1. If our x was equal to 1, our y would be 0. If our x was equal to 2, our y would be minus 1. If our x was equal to 3, our y would be minus 2. And for now, let's see what we can do with just these values here. So let's start off with our first equation here. Let's plot these values and start to graph them out and see what we get. So we have here that when x is equal to negative 1, our y is equal to 5. So here's negative 1. And here's y is equal to 5. So let's just put a little mark here. Then we have when x is equal to 0, y is equal to 3. So here we have x is equal to 0, and we have y is equal to 3. So we can put a mark here. When x is equal to 1, y is equal to 1. So when x is equal to 1, y is equal to 1, that's going to be a point right here. When x is equal to 2, y is equal to negative 1. So when x is 2, we have y as negative 1, which is about here. When x is equal to 3, y is negative 3, so we have x is equal to 3 and y is equal to negative 3 over here. And when x is equal to 4, we have y as negative 5. So here's x is equal to 4 and y is equal to negative 5 right here. So that will be a point here. Now we can try and join these dots in a single line. So that is going to look like that. Now let's do the same thing with our second equation here. So when x is equal to negative 1, y is equal to 2. So we have -1 here and y is equal to 2 up here. So we can color that in. And when x is equal to 0, y is equal to 1. So here we have x is equal to 0 and here we have y is equal to 1. So that's going to be a point right there. When x is equal to 1, y is equal to 0. So here we have x is equal to 1 and y is equal to 0. So that's going to be a point right there. When x is equal to 2, y is equal to -1. So here we have x is equal to 2 and here we have y is equal to -1. So this is going to be a point here. And when x is equal to 3, y is equal to -2. So here we have x is equal to 3 and here we have y is equal to -2. So that's going to be a point over there. So we can also now join these dots in a line that looks like that. So one thing that we can notice about this is that the point at which both of these two graphs are going to intersect is right here. Our point of intersection, where both graphs are going to be equal, is when x is equal to 2 and y is equal to -1. So our x value is 2 and our y value is -1. That is the coordinate at which both of these graphs are going to intersect. And it turns out that when we are solving simultaneous equations, if we graph out both equations and figure out the coordinates of where both graphs intersect, that is actually going to give us our values for x and our values for y. So when we try to solve these simultaneous equations graphically, we are going to get that x is equal to 2 and that y is equal to -1. And we were able to do that without having to rearrange any of these equations and do either substitution or elimination. We were just able to look at this graph, see where both of them intersect, and write down our value for x and our value for y. So let's actually try and solve this using substitution to see if we get the same answer as we did when we solved this graphically. So let's just get rid of this right here to give ourselves some more space. Now let's try and solve this with substitution. And let's first try and get this one in terms of y. So if we were rearranging this for y, we would get y is equal to 3 minus 2x. And now we can plug in this value for y into the second equation. So we get x plus 3 minus 2x is equal to 1. And now we can solve for x in this equation. So we have x plus 3 minus 2x is equal to 1. X minus 2x is going to be minus x plus 3 is equal to 1. We can bring this plus 3 to this side, so it becomes minus x is equal to 1 minus 3. And that gives us minus x is equal to a minus 2. So x is equal to 2. So now we have found our value for x, and what we can now do is plug in that value for x into either one of our two equations and solve for y. So let's try plugging in this value for x into our first equation here. So we would get 2 times 2, because we're plugging in 2 for this value of x here, plus y is equal to 3. So that, if we just give ourselves a bit more space here, that is going to be 4 plus y is equal to 3. If we move this 4 to this side, we're going to get y is equal to 3 minus 4, and that will give us y is equal to -1. So we have found our value for x and we found our value for y. And as we can see, these are the same values for x and y that we got when we solved this graphically. So this shows us that we can solve simultaneous equations using either substitution, like we just did here, using elimination, which we did a few videos ago, or you can solve it graphically by graphing both of those equations and seeing the point at which they intersect, which will give you your value for x and your value for y.